Still on the series of surds, we are going to look at finding the square root of a surd. Surds have square roots also. So, how do we get the square root of a surd? First of all, I'm going to let the square root of my surd, which is a 22 plus 12 root of 2, to be equal to, since I'm getting a square root, so it's a plus or minus the square root of x plus the square root of y. So the square root of a surd is also a surd. That is the first thing a learner should know. The square root of a surd must also be a surd. And since this is a plus, here I use a plus. If it's a minus, I use a minus here. Then at the next step, I square both sides. So squaring this side, the square root will cancel. I'll have a 22 plus 12 root 2 being equal to, when I square here, this is going to, let me write it for you. Of course, this negative will cancel. I stay with positive only. This, so I'm going to expand this. And what shall I have? So this is a 22 plus a 12 root 2 is equal to, when I square this, becomes x plus, remember, it is in this form. It is in the form of root x squared plus twice the product of root x times root y, then plus root y squared. If a learner remembers something like this, then it becomes very easy for you. This is plus 2ab plus b squared. It is what I'm following to expand. Then I'll have 22 plus 12 root 2 being equal to, this is x plus 2 root of xy plus y. Because root x squared, like I told you, is the same as saying root of x times root of x. And I told you, if you have a surd multiplied with a surd, you just get that value without a surd. So that's why root x squared becomes x. Or someone will say this is square cancels with the square root. You stay with just x. So I can proceed from this point, and I have to compare. I'm going to compare terms. Comparing terms, the ones that are not having a surd, I compare them alone. The ones with a surd, I also compare them alone. Now, I'll have 22. I compare the other side, it is equal to x plus y. And you can call that equation 1. Then I look at the surd now. The surd is a 12 root of 2 is equal to 2 root of xy. Before you call this equation twice, see some values can reduce by 2, 1, by 2, 6. So I have a 6 root of 2 being equal to root of xy. Then before still I call it equation 2, I square both sides such that I eliminate the square root sign. When I square this one here, this becomes 36 times 2, which is a 72, is equal to xy. Then from this, I need to make either x the subject or y the subject. So if I make y the subject, divide through by x, I'll have a 72 over x. Now this is my equation 2. Remember, I have equation 1 with x and y. I also have equation 2 with x and y. But now I've made y the subject. So I'm going to get this y value and substitute it in here, such that I have 22 is equal to, my x value is just x plus 72 over x. Now, when I reach at this point, what I'm interested in is getting rid of this x in the denominator. How? Multiply it here, here, and here. When I multiply it here, it becomes just 72. When I multiply it, it becomes 22x is equal to, when I multiply it here, it becomes x squared plus 72. Then I have the 22 go the other side, such that I have 0 is equal to x squared minus 22x plus 72. This is your quadratic equation which you can solve simultaneously. Let me write it as x squared minus 22x plus 72 is equal to 0. Now, we have come up with the quadratic equation, which we can deal with simultaneously. You get those two terms whereby if you multiply them, you have a negative 72. When you add them, you have a negative 22. When I look through, I have a negative 18 and a negative 4. Because negative 18 minus 4, I have a negative 22. Then if I have a negative 18 times negative 5, I have a 72. So I'll have it as x squared minus 18x minus 4x plus 72 is equal to 0. Deal with two terms here and two terms here. Factor out the x, you stay with x minus 18. Then factor out the negative 4, you stay with x minus 18. This is equal to 0. This bracket must be equal to this bracket for as long as the value is the values you've got are correct values. So at this point, I've factorized completely. Get this x minus 4, put them in the same bracket, then into x minus 18 because it is the same. So you just take on one. Then I'll say either x is equal to 4 or x is equal to 18. Where is x coming from? X is equal to 4 is coming from getting this and get to 0 after applying the 0 rule for brackets. If they are multiplied, you just equate each term to 0. Even if there was another value here of x, you say either x is equal to 0 or x minus 4 is equal to 0 or x minus 18 is equal to 0. That only and only works if there is a 0. If there is a 1, expand, solve it just like any other quadratic equation or polynomial. We have got x values, but we need y also. So you come from equation 2. Remember, we said that y is equal to 72 over x. But now, if x is 4, our y value is going to be 18. So here we have our x and y values being equal to x is 4, this 4, then y is 18. Remember, they are the values that we want. That is the square root of our surd. Then, or the other, if x is 18, for x is equal to 18, we said that y is equal to 72 over 18, which y value of ours is going to be a 4. So meaning that also xy is equal to 18, 4. Now, how do we conclude? Since we said that the square root of 22 plus 12 root 2 is equal to a plus or minus, open brackets, root x. So root x, if I take this one here, root x is root of 4 plus root of what? Root of 18. Remember, we said it is plus or minus root x plus root y. But this is not the final answer. Why? Root 4, I know the square root of 4, which is a 2, plus, still this 18 has two terms whereby one of them has a perfect square root. That is 9 times 2. So what do? We can get the square root of 9, which is going to be 2 plus the 3 comes out, then I stay with the root 2. This is the final answer. So the square root of a surd, therefore, is equal to a surd. Now we see that the square root has stayed there, which is the surd. So that is how we deal with square roots of surds. Key points you should not forget here. Like it or not, you'll come up with a quadratic equation, which you'll have to solve if the factors are there. Solve, get the value of x. Most of the times they keep interchanging because you might be wondering, why haven't we used this pair also? With addition, well, we said that if now this is the y and this is the x, we substituted for this as being our root 4 for the first one to be our x, root 18. But you have to take it in consideration that anything you start with, root 4 plus root 18 is the same as root 18 plus root 4. Addition is commutative, it does not affect anything. So thanks for watching. We meet in the next video.